Welcome back, Physical Science 20. So this is the second part of the video. So we looked at molar mass and going from moles to grams. Now we'll do some vice versa questions going from grams into moles. So here, 22.6 grams of sodium nitrate into moles. So of course, going from grams to moles, multiplied by 1 mole over the molar mass. So since these are compounds here, we have to do a side calculation here, silver nitrate. So for every 1 mole of silver nitrate, there's 1 mole of silver, 1 mole of nitrogen, 3 moles of oxygen there. So adding those up, 169.9 grams per mole, and we get that. So 22.6 multiplied by 1 divided by 169.9, 0.133 moles silver nitrate. Okay, kind of a revision of the Y chart. I just left off the volume one because we'll look at that later. Going from here, mass to moles to particles, etc. There's also, we talked about moles of ions, which could fall into this category, but here, when we talk about how many individual ions, that kind of stems off of this bubble here. So when you have your particles, whether we're dealing with atoms, molecules, or formula units, we could go into ions or atoms by looking at what the formula is itself. Okay, so this is kind of the key that we're going to be looking at for the next, the last page. So here, so questions 31 to 35 on pages 325 to 326, I believe. So 25 grams of Ag2CrO4, how many silver ions are present? So we can see that Ag2CrO4 has 2 silvers there. So first of all, we need to go from grams to moles. Now, since this is a metal and this is a non-metal group, we call this a formula unit. It's not an atom, it's not a molecule, it's an ionic compound, so it's a formula unit. So, and then from ions. So again, the path here, grams to moles to formula units to ions. So it's going to be a 3-step conversion actually. So we need to find the molar mass, use that conversion, and then using the formula to figure out how many ions there are. So take a look here, gang. So moles, so we have our molar mass here, 2 silvers, 1 chromate, 4 oxygens, so that adds up to be 331.8 grams per mole. So the first part here, so converting into using the molar mass there, grams on the bottom, moles on top, so I can cancel grams. It's crucial that you show this canceling because then you can't make a mistake. If your units cancel, you have it set up right. So now we're in the mole bubble. Okay? So we've done this step. Next, we need to go with this step. So multiply by 6.02 times 10 to the 23rd over 1 mole. So multiply by 6.02 times 10 to the 23rd over 1 mole. And that'll take us to here. Now, depending upon the formula now, that determines what I have for this last step. So if I have 1 silver chromate compound, I have 2 silvers. So the terminology that we use there is formula unit. If I have 1 formula unit of silver chromate, I have 2 formula units of silver ions. So for every one of these, I have 2 silvers. So that works out to be 9.36 times 10 to the 22, and we refer to that as formula units of silver. Okay? Find out how many CrO4 2- ions there are. It's going to be identical. So we have convert grams to moles, then moles to formula units. The only thing different is this last step. For every one of these Ag2CrO4s, I only have 1 CrO4. We're treating the CrO4 as one group because it's 1 negative ion. So this time it's a 1-to-1 ratio, so it doesn't change. Okay? And then here, look at C, what is the mass of one formula unit of Ag2CrO4? So formula units to moles to grams. So formula units to moles to grams. See, you got to find the path you're taking, then it's easy. So this time we're going to divide by 6.02 times 10 to the 23rd. Be sure you type this in your calculator right. Use the EXP or the double E button. And then of course we figured out the molar mass earlier, so that's easy. 5.51 times 10 to the minus 22 grams Ag2CrO4. Okay, so we have this one now. Now let me see here what I have here, because I don't think I worked through all of these. Let's see, I worked through that. So if you look at 32 here, 4.59 times 10 to the 24 formula units of sodium chloride, how many grams is that? That's very similar to part C of this question here. So you need to, so from formula units to grams, formula units to grams, you have to go through moles, then grams. So you should likely do this question. The answer that you should get is 446 grams of sodium chloride. Okay, where am I? There I am. Someone turned out the lights. There we go. So this time I have a molecule, because these are all nonmetals. So we're dealing with atoms and molecules here as opposed to formula units. The process is the same though. So molar mass of C2H5OH, we have 2 carbons. Total of, let's see, 5 plus 1, that's 6 hydrogens and 1 oxygen. How many carbon atoms are there in 45.6 grams? So we're going from grams to moles, moles to molecules, molecules to atoms. So once again, depending upon the substance we're using, this could be ions or it could be atoms. If we're dealing with molecules, we're talking about atoms there. So very similar to the other one. So 45.6 grams and then times 1 mole over 46 G's, because that's the molar mass. So cancel, cancel. We're left with moles. Then 1 mole is 6.02 times 10 to the 23rd. And let's see, this is a molecule, see, because they're all nonmetals. Moles cancel. And then, so that's molecules of C2H5OH. And of course, for every 1 molecule of that I have 2 carbon atoms. So that is that final part right there. Okay? So that works out to be 1.19 times 10 to the 24 atoms of carbon. How many hydrogen atoms? Maybe pause the video right now. You figure it out. Going to be very much the same thing except this last step. Okay, so go ahead and try it. Okay, if you had a chance to do that, every step is the same up until this point where we get to the end. Molecules of C2H5OH. For every 1 molecule of C2H5OH, there is, let's see, 5 plus 1, 6 hydrogen atoms. So there's our answer right there, 3.58 times 10 to the 24. If we go with oxygen, you can see here, for every 1 of these molecules, I have 1 oxygen. So the only thing that changes is the end. And of course, the end isn't going to change because it's 1 to 1. 1 molecule has 1 oxygen atom. And that works out to be 5.96 times 10 to the 23 atoms of oxygen. Okay. I guess the last one here I have sodium sulfite. Sodium's a metal, sulfite are nonmetals, so here we're dealing with formula units again and ions. Number of sodium ions. So here I worked out the molar mass of sodium sulfate. 2 sodiums plus 1 sulfur plus 3 oxygens, 126.1 grams per mole. So setting that up, 2.25 grams multiplied by 1 mole over 126.1 grams, so that cancels. Then 1 mole of sodium sulfite is 6.02 times 10 to the 23 formula units, so moles cancel. Then of course 1 formula unit of sodium sulfite has 2 sodiums. So there you have it, 2.16 times 10 to the 22 sodium ions. How many sulfite ions? And sulfite is the whole SO3 group. It has a total charge of 2 negative if you look in your periodic table. And you can see here for every one of these I have 1 sulfite. So the only thing that changes again is that last part. 1 formula unit has 1 sulfite ion. Then going backwards, what is the mass of 1 formula unit of sodium sulfite? So again, we're going in the reverse order there. Let's see, where is that Y chart? There it is. So formula units to moles, then from moles to mass. So 1 formula unit, multiply 1 mole over 6.2 times 10 to the 23rd, so that cancels. And then moles to grams, so 2.09 times 10 to the minus 22 grams of sodium sulfite. Now I didn't do the last question here because it's very similar to these ones, and plus we're running out of room here likely. So there you have it. So that's the 11.3 using molar mass to go from grams to formula units, vice versa, also including ions and atoms into that mix. Okay, see you soon.